We're beginning Unit 4, Function Composition or Function Combination. Today we're going to start with Lesson 1, Combining Functions Graphically. So pick up your notes packet from the blue basket. We're going to use that packet throughout this week, so you can highlight, you can mark in it, you can take notes. Start the warm-up in Delta Math for Monday. You have until midnight to get the grade that you want, and whatever warm-ups we do for the week will be averaged in for one grade. All right, turn in your packet. You should see a absolute value function on the top. That's y equal f of x. And then you'll see a linear function on the bottom. That's y equal g of x. Draw this table. We're going to pick some points from f of x and g of x, and then we're going to combine those two functions, f plus g of x. So I'm going to start with the absolute value function, and I'm going to choose values in the second quadrant and in the first quadrant. So I'm going to start on the left, and I'm going to pick negative 8, 8. Plot that point, and then I'll pick negative 6, 6. You can pick whatever points you want, but I want enough points in both quadrants and also at the origin where I can evaluate. And I don't want them to be difficult, so pick whole numbers. I'm going to go to negative 4, 4, plot negative 4, 4, negative 2, 2, plot that point, 0, 0, and we're going to start working our way up on the right. So I'm going to go back to 2, 2, 4, 4, 6, 6, and 8, 8. Okay, we have those points plotted. That's our absolute value function. Now, g of x is a linear function. It intercepts the y-axis at negative 2, and the slope is 1. Up 1 over 1. Y equal x minus 2. All right, so I'm going to take the same x value, start with negative 8, and on that linear graph, I'm going to go to negative 8 and then go down and find my corresponding y value. So negative 8, that would be 10, so I'm going to plot that point. And then I'm going to move to negative 6, negative 8, plot that point. I'm using the same x values. I'm just finding the corresponding y value for function g. Okay, so I'm going to go next to negative 2, and I'm going to find the corresponding value on that linear function at negative 4. And then at 0, goes down to negative 2. And then at 2, we're at 0. And then at 4, we're at 2. 6, we're at 4. And 8, we're at 6. All right, now I'm going to add those. So we're going to combine with addition. Okay, look at your rules. Choose the corresponding points on each function. So we chose some corresponding points. We're going to determine which operation we're doing to combine the functions. So our operation is addition. We're going to apply that operation using only your y values on your function. So again, we're going to have the same x values, the input. So f plus g of x. X is always going to be negative 8 for the first point, negative 6, negative 4, and so on. So you can go ahead and fill in your x values and then simply add your y values. So you can see that first point is going to be negative 8, and it's not negative 2. Let's take another look at that. Okay, 8, take away negative 10. We're going to be adding 10, so that should be negative 8, 18. So correct that on your paper as you're drawing in your table. Okay, the second point, the x-coordinate is -6. -6 take away -8 is going to be, oh, I'm sorry, this is correct. We're adding. So 8 plus -10 is -2. 6 minus 6 plus -8 is -2. Okay, that third one, 4, we're only looking at the y values. 4 plus -6 is -2. Keep plotting those points. And then 2 plus -4 is -2. But then at 0, 0 plus -2 is still going to be -2. The next point, we start with 2, and 2 plus 0 is 2. So it's going to start going up. Okay, and then the next x value is 4. And then the y values combine 4 plus 2, you'll get 6. And then for 6, combine your y values. 6 plus 4 is 10. And then for 8, for our x value, 8 plus 6 is 14. So I've plotted those points in green. Now let's connect the dots. Okay, and this is what our graph looks like in green. Now let's move over to and perform the same thing with subtraction. I'm just going to use fewer points this time. You get the idea. So I'm going to plot -8, 8 on that top function, on that absolute value function, -2, 2, 0, 0, 2, 2, and 8, 8. So I've got the origin and points on either side in that first and second quadrant. Okay, now I'm going to subtract, but I need some points on function g. Okay, so let's look at function g and let's find some corresponding points with the same x coordinates. Okay, so if I look at -8 and I go down to that linear function that matches with -8, -10, -2 is going to be -4, plot that point. 0 is going to be at -2. 2 is going to be at 0. And 8 is going to be at 6. So now we're going to subtract those and see if we can have enough points that we can graph. All right, so that first point is -8, and this is where you get 8, take away -10, so we're going to be adding 10 to get 18. That's going to be a little bit off my graph. I'm going to put it up here. It's about there. And then we're going to have the x value for that second set of points at -2. Let's add our y values. 2, not add them, subtract. 2 take away -4 is 2 plus 6, 2 plus 4, which is 6. And then at 0, we have 0 take away -2, so that becomes 0 positive 2. And then at 2, we have 2 plus 0, so that's going to be 2. And then at 8, we have 8 plus 6, which is 14. I'm sorry, I'm subtracting. I need to remember that I'm subtracting. So 8 take away 6 is 2. Let me double check. 2 take away 0 is 2. 0 take away -2 is 2. 2 take away -4 is 6. And 8 take away -10 is 18. All right, let's connect the dots. And this is what this graph looks like. Now we're going to combine functions with subtraction. But before we do, let's look at the domain and the range. The domain is what can your x values be, your inputs can be x such that x is any real number. Let's use this notation. And then our range is y, and our y values are greater than or equal to -2, so they go up. Okay. For this combination with subtraction, our domain is x, again, any real number, and our range is y, such that y is greater than or equal to +2. Now we're going to move on to subtraction. So we're going to be using the same 3 rules. Okay, choose corresponding points on either function. So we're going to correspond the x part of the coordinate, the x value, and then determine the operation that we're doing to combine the y values. We're only operating on the y values. Okay, this time we're going to be looking at multiplication and division. Okay, so let's start with some points on the absolute value function. So I'll choose -2, 2, -1, 1, 0, 0, 1, 1, 2, 2. Okay, I think that's going to be enough. Let me do one more. Okay, so find the corresponding y value on function g. So we're looking at the graph. G is going to be the linear function. So at -2, y, the output is -4. At -1, the output is -3. At 0, the output is -2. At 1, the output is -1. At 2, the output is 0. And at 4, the output is 2. So let me plot those points. When I combine them with multiplication, okay, I'm going to go ahead and put those in my graph, in my chart, and explain. We're only looking at the y values. 2 times -4 is -8. 1 times -3 is -3. 0 times -2 is 0. 1 times -1 is -1. 2 times 0 is 0. 4 times 2 is 8. So I plotted all those points, and then I'm going to connect those. This time it's not a straight line. It ends up being a cubic. Now let's go to division. Okay, I'm going to pick these points: -8, 8, -4, 4, -2, 2, -1, 1. I'm going to choose a few more points because division is going to be the trickier one. 1, 1, 2, 2, 4, 4, and 8, 8. Let me make sure I get enough points. So I'm going to go to my function g, find the matching points. We're using the same graphs, so you should be able to pick up on this quickly. Okay, so start at -8, and then we're going down to the linear function, and that is going to match up with -10. Okay, so let's go ahead and fill these points in and plot them. -4, -6, -2, -4, -1, -3, 0, -2, 1, -1, 2, 0. Just picking corresponding points, 4, 2, and then the last point would be 8, 6. Now again, we're going to have the same x value for each coordinate that matches up with our pairs for function f divided by g of x. So we're going to only be dividing the y values in each coordinate. So the first one I'm going to start with is 0, 0, or 0, and then 0 times -2 is 0. I'm sorry, 0 divided by -2 is 0, because you can divide 0 by a number. Then I'm going to move up or move down to the next point, and so 1 times -1 is -1. I'm going to move down to 4 for the x coordinate, for the x value of the coordinate, and 4 times 4 divided by 2 is 2. I'm looking for numbers that are easy to divide. And I've kind of run out of easy ones, so I'm going to go back up to the top. -8 is my x value. And then 8 divided by -10 is -8/10. So I'm just going to write that as a decimal, -0.8. Okay, then I'm going to move to 4 divided by -6 is -2/3. If I reduce that, because if I write it as a decimal, it's going to be a repeating decimal. And then I'm going to move to the next one. 2 divided by -4 is -1/2. And then I'm going to have to deal with these that are not so fun to deal with. The repeating decimal, 0.3 repeating, or -1/3. I'm going to skip 2 as my x-coordinate. I'm going to move down to 8. 8 divided by 6 reduces to 4/3. And then finally, with 2, 2 divided by 0 is undefined. So that means we have an asymptote at x equal 2. So let's go ahead and draw that asymptote in at x equals 2. So we're going to be approaching from both sides. And let's connect some dots here. Okay, over on the left, okay, I'm drawing, and it looks like it's really hard to see. I need a bigger graph. Starts down low, goes up a little bit each time. It hits the x-axis, and then it goes down, and it approaches that asymptote. But it never touches or never crosses. On the left-hand side, we can see that it starts high, but it's never gonna, it's gonna look close. It's gonna look like it overlaps until you zoom in really closely. Okay, we have a point here. It's gonna go down. It's gonna keep approaching that x-axis, but it's not gonna touch there either. All right, so that's how we graph that with those two functions combining with division. Let's look at our domain and our range. Our domain for multiplication is going to be the set of all real numbers, and our range is also the set of all real numbers. For division, our domain is going to be any value except for 2, where we have an asymptote. And our range is going to be any, it looks like it covers all real numbers. Okay, because we do have a point here on the x-axis. All right, let's move on. Now we're going to evaluate composite functions with sets. We're using the set notation where these are our inputs, our x's, and these are our y's, or our outputs for function g and function f. All right, we're going to consider these two functions, and we're going to combine function g with function f. So we're working from the inside out, or right to left. So we're going to start with g of -1. So let's find function g. Our input is -1. Our output is 2. So this is going to be 2. We're going to put that 2 into function f. So function f, when we input 2, we get 3. So the answer here is going to be 3. For b, go back, sorry. So our answer here is 3. All right, for b, we want f of 3. So we're going to go to function f, and we're going to input 3, and our output is going to be 2. So once we get 2, we're going to put that into function g. So go over here, put in 2, and our final answer is 5. All right, now we're going to have g of 0. So we're going to start with function g. Input 0, our output is 1. So we get 1 right here. So we're going to put that back into function g. So at 1, if we input 1, we get out 2. So this answer is 2. And then finally, f of 2. So we're going to go to function f, input 2, our output is 3. So we're going to take that 3 and we're going to put it back into function f. So we're going to go right here and put 3, and we're going to get out 2. All right, and now we're going to look at tables, and we're going to use those to determine our function combination. Okay, so we're going to start with f of 2. So find function f, input 2, and your output is 0. So once you have that answer, you're going to put that into function g. If you input 0, you get 1. Okay, for b, okay, we're going to start on the inside, g of 2. So we're going to go to function g. We're going to input 2, and our output is -1. Okay, put -1 back into g. So we're going to go up here, put in -1, and our answer is 2. All right, now we have 2 graphs. We're looking at graphs again. And we're going to combine these functions not with an operation, but with function composition. Okay, so we're going to start with g on the inside, g of -2. Let's find function g. Here's function g. Okay, we let our x value be -2. And I cannot draw a straight line with this mouse. And go up and find our y value is 8. And then we're going to put 8 in for x into f. So when x is 8, y is 3. So f of 8 is 3. All right, now this time we're going to find f of 3. So we're looking at function f. We're going to 3, and our output is 2. So we're going to take that 2, and we're going to put it into function g. So g of 2 is right here, 0. Okay, find g of 2. We already found that. That's 0. And we're going to put 0 into function f. Okay, so we're going to go over here to 0. And we're looking at function f, and that ends up being +1. Okay, now we're going to start with f of -1. So we're going to go to -1 right here. And then f, our function f, is our inverted parabola. Okay, so that's going to be 0. F of -1 is 0. Okay, so now we have that answer. We're going to put that into function g. So g of 0. When we're at 0, we're going to go up to this linear equation, and we're at 4. All right, these are notes that are in the worksheet that you're going to practice on today. So what it's saying is I have a function f, I have a function g, and I can combine g with f and f with g. Now, you're not going to get the same answer if you change the order of combination. So let's look at f of g of x. So we start with x, okay, and function g. If g is a, our output is 1. Then we're going to put 1 into our function f, and our output is d. Okay. All right, now let's look at function g of b. So g of b, look at function g. G of b is 3. You take that 3, you put that back into function f, and we get e. Okay, and one thing I want you to notice is that when I do G of C, okay, C, our output is going to be 5. Okay, but when we put 5 into function f, we don't have a place to put it. Okay, 5 is not in the domain of f, so the output is the null set. It cannot be found. So there's no solution there. All right, so some notes to continue. You always start with the inside function. You input the x, you solve for y. So the x is not going to change. Okay, you input the x, you solve for y. Put your output into the other function and solve for y. Okay, combining graphically. Choose the corresponding points on each function. Determine which operation you're doing to combine the functions. When you're adding, subtracting, multiplying, or dividing, this is what we're talking about. And you apply that operation only on the y values. The x values stay constant. All right, you have a worksheet to complete, so work on that. Bring that back on Tuesday, and we will answer any questions before you turn that in.